At all levels, fishery products play a critical role in food security and in our nutrition. Global fish farming is increasing at the rate of 3.1%, which is way more than the growth of any other food crop. But how far are we from a sustainable aquaculture? Stay tuned in today's video. We look at the future of aquaculture and discover how sustainable fish farming actually is. For example, the wheat production worldwide has been at the same level from past 7 years. So what is the reason behind the increase in fish farming? Guess maybe we have somehow started to love sushi more. So have we changed our meals? Or maybe it is happening due to something else. Let's dive in and look at the massive work going on in fish farming technologies. Global fish production was predicted to be over 179 million tons in 2018, with aquaculture accounting for 82 million tons. Between 1961 and 2017, the average annual growth rate of worldwide fish consumption for food was 3.1%, nearly double the average annual growth rate of the world population during the same time period. The rate was also higher than that of other animal protein foods, like meat or dairy products. However, aquaculture faces many challenges in meeting this demand for fish due to pressure from human activity. Things like overfishing and climate change that has an impact on natural resources like ocean acidification. As a result, there are calls for more sustainable practices and technologies to be implemented in the industry so it can continue growing while remaining profitable. The main reason behind this is that fish has become one of the most important sources of protein in diets around the world. According to statistics from the Food and Agriculture Organization, more than 26% of global animal protein comes from fish products. Welcome to Future. Don't forget to like this video and subscribe to our channel for everything on future technology. So what can be the reason for the tremendous growth in aquaculture? Possibly there can be two reasons though. The advanced futuristic technology, and it explains what the future is going to be all about. Stick to the end of the video to find out the other non-technological reasons too. Do you think that simply using better information technology can help boost intelligent farms? Traditional aquaculture IoT systems had a high level of cloud and Internet of Things integration. It is organized into 3 layers: device layer, network layer, and cloud service layer. Sensing devices, control equipment, and a data collecting terminal make up the device layer. The sensor equipment is in charge of gathering environmental data such as DO, pH, temperature, salinity, ammonia, nitrogen, nitrite, water level, and so on, as well as the device's operating status and aquaculture video picture data. Aerators, oxygen cones, feeders, pump values, and other aquaculture equipment are included in the control equipment. The data acquisition terminal is in charge of transmitting sensor data upward and receiving control instruction. Finally, the cloud service layer adopts centralized storage architecture to save all sensor data generated by devices. Main environmental aquaculture effects. As the aquaculture industry grows and expands, it has a greater impact on the environment. Nutrient pollution from uneaten feed and metabolism, chemical pollution from different drugs used in the production process, and the spread of farmed fish genes, parasites, and diseases to wild populations are some of these effects. The substantial impact on aquatic ecosystems caused by the requirement to feed carnivorous species of farmed fish with wild fish is an important indirect effect of the production process. However, it must be noted that there are other direct effects, such as landscape degradation due to eutrophication or water pollution from aquaculture facilities. Unbelievable innovations that have and are transforming aquaculture. Reproduction innovations leading to better. Biotechnology is being used to improve the reproductive and early development of cultured organisms, as well as increase the supply of gametes and fry. It is assisting to discover and protect aquatic biodiversity by enhancing reproductive success and survival of endangered species. Disease management, the most important thing indeed. The ramifications of newly developing illnesses in aquaculture are causing increasing concern. Because traditional ways of managing such diseases ineffective against many novel infections, particularly viruses, molecular techniques for pathogen screening and identification are gaining popularity. Feed technologies, no more regular expensive feeds for our sushi's fishes. By improving production and processing procedures, new technologies provide prospects for the development of alternatives to fish meal, particularly plant-based protein sources. Unexpectedly, new species are being introduced to aquaculture. Existing culture technology, existing market demand, and expected high profit are typically used to justify the introduction of a species to a new region as a target agricultural species. Producers of fish expect a quick profit because a species that can be mass-produced with existing technologies and has a proven market demand shouldn't require any additional technological or market development investments. Tilapia, African catfish, and shrimps, for example, have grown in popularity to an unhealthy level. Ranching program success factors have improved, and interest in this technique has expanded to new places and species. For a range of species, many countries have begun stock improvement efforts. All technological transfer to the aquaculture sector must take into account the protection of wild aquatic biodiversity as well as potential repercussions on rural and subsistence populations' autonomy and economies. The importance of biotechnology in terms of food security, poverty reduction, and income production is growing, and we must be prepared to face the problems that this will entail, as well as develop these technologies responsibly. Wait, technology isn't the only thing here, but here are 4 globally changing trends which are influencing the future of aquaculture. 1. Land-based aquaculture, RAS and flow-through. Many visionaries of aquaculture believe that land-based farming is the way of the future. Environmental concerns about ocean-based activities and the notion that there must be a better way led to the development of this unique and cutting-edge approach to fish production. Because of Atlantic Sapphire's successful initial commercial harvesting, the viability of the land-based method continues to grow, generating an inflow of finance and expertise. Recirculating aquaculture systems and flow-through systems are the 2 most often used methods nowadays. Each technique has ardent supporters who support and implement it, making decisions based on the benefits and drawbacks of each. RAS is a method in which water is constantly recirculated through a fish tank, reducing resource requirements while artificially maintaining a healthy, natural environment for the fish. RAS uses substantial biofiltration to maintain water quality over time, monitoring and modifying important parameters like oxygen and ammonia. 2. Adoption of advanced technology. Fish farms may become much more profitable, humane, and sustainable if they use cutting-edge technology. This reality has aided their widespread adoption across the sector. Farms, for example, are increasingly dependent on artificial intelligence tools to gain access to data that was previously unavailable. Farms can better manage their sales by using AI to estimate biomass, avoiding overproduction or underproduction of fish to satisfy demand. Because feed accounts for over 70% of a typical land-based farm's costs, automation and efficiency can enhance profits and sustainability dramatically. Fish health analysis can be performed to ensure that the fish are happy and healthy while also determining and limiting the company's risk. 3. Biosecurity. Scotland reported disease-related fatalities of approximately 25,000 tons of farmed fish in 2019. This was an all-time high, accounting for 13.5% of the overall harvest. Aftermath resolving these challenges is critical. Maintaining the health of salmon and other fish is crucial for long-term fish farming. Algal blooms, illness, sea lice, and pesticides pose major dangers. Antibiotics that prevent illnesses increase the spread of hazardous, contagious bacteria outside of the farmed fish population, while algal blooms can release poisons and reduce oxygen levels for fish. According to some estimates, treating sea lice costs the business about $1 for every kilogram of farmed salmon. 4. Economic impact. Aquaculture has seen a remarkable economic boom in the 21st century, with numerous countries increasingly desiring and producing fish. As a result, they benefit from the industry's economic stimulation. According to the World Bank, the total amount of aquaculture-supplied fish would exceed 93.6 million tons by 2030. For the first time in history, aquaculture-supplied fish, 97.11 million tons, surpassed wild-caught fish, 91.75 million tons, in 2013. This is on top of the fact that during the last 50 years, the average person has ingested approximately twice as much seafood. Many countries continue to contribute to aquaculture's rapid expansion. From 1990 to 2016, the production of aquaculture in metric tons in a few nations increased exponentially. We are sure about one thing, that with future aquaculture, Bill Gates is going to change his mind a bit. Bill Gates explained that raising a chicken is the most profitable business with among the best ROI. Maybe future aquaculture will also take its place in his statement. What do you think about that? Will aquaculture farming be next? Let us know in the comment section below. And don't forget to subscribe to our channel to stay updated on anything on future technology. Thank you for watching.